I recreated this extremely messy room using just 50 fisheye images and gsplat's new integration with 3D Gaussian Unscented Transforms. And yes, this was done on Windows. So all you fans who wanted to make this but didn't have Linux for the original repository, you can use this one. And I'm gonna walk you through how to do it step by step so you can capture your own messy room and make a really cool scene. And then later on, you can do these cool effects like I'm showing right here, where you can like make it look fisheye and spherical and all these cool things. So anyways, let's jump into the repository, which I will have linked in the show comments and you can follow along. To get started, I created a custom fork of gsplat that specifically just covers how to install gsplat and run 3D GUT within gsplat. So there is more instructions if you go to the main version, which you can see here forked at the top. However, I omitted a lot of information to make things easy for you. So if I come down here, I say, about this project, again, it'll say, this is basically just for Windows PC, how to get it running. And if you want to use this on Linux, things like that, go back to the original gsplat. You can run it there too. And here's some references. But we're just going to run through this and we're going to get this installed. And I'm going to kind of start from ground zero, but some of these dependencies I already have installed. So I'm not going to reinstall them again, but I can show you what to do. So the first thing you'll need is Git. So if you have never pulled anything from GitHub, you need what's called Git. If I download it in here, this is super easy. Pick Windows. It's an installer. Not really going to go beyond that because we've all run installers. Same with Miniconda. You need Anaconda or Miniconda. Again, if you come here, you can free download the distributable so you don't have to do it through command line. Super easy. And just want to point out, if it asks if you want to add Conda to path, yes, you do. So when you try to make an environment, it knows how to find it off a command. And then you'll need Visual Studio 2022 and make sure you get the desktop development with C++ workflow. It's imperative that when you install Visual Studio, that you do that before you install CUDA Toolkit. So if you already have CUDA Toolkit, you got to go back and reinstall it or install a different version, because then it'll add some sort of code to Visual Studio to make sure it's all enabled. And then PyTorch, which is further below. So basically when you have Visual Studio, there's some tricks here. They have this installer that you'll install, and you'll see I have 2019 Professional. A little tip here: if you're using if you're trying to use CUDA Toolkit 11.8, it won't work with the newest version of Visual Studio, but you can download the Professional version, and that version you can use for free, even though it is a paid tier, because you're not actually using the software to develop your own software. You're basically just use it as a compiler. So it just needs to be installed on your computer. It's nothing too fancy there. If I go to modify this, you can kind of see what I'm talking about, where you need this desktop development with C++ tools. And then there's all these things on the right that are kind of optional. You want to make sure you have this MSVC 142. Just kind of like, if you see any of those, just check them all on, make sure you have all of those. I have some older ones as well. If you have the newer installer, the Visual Studio 2022, there's I think an MSVC 143. So just make sure you have those kind of check marked on. I don't know if they're default always. So when you install that, that'll take some time. If you don't have all that already reset up, that'll take some time. And then you'll need the latest CUDA Toolkit and PyTorch. So we're just going to kind of move along because you're going to come back to that. So now I'm going to create an environment. So the first thing I want to do is go to my command prompt. And I promise when we install all this, it's a lot of setup, but once you have it installed, it's super easy to run every time. You just kind of have to go through this pains. So with these, I'm just grabbing one line at a time. So what we're going to create is an environment called gsplat. So it's going to basically be a container for all this code that we install, and it won't cross with other code and create all sorts of issues down the road. Imagine it's like you separated out a room to store all your stuff for this project in your house. And you don't want anything to get crossed into other rooms. So basically just making a separated area. And this should go pretty quick, as you saw on my computer. And then we need what's called activate that environment. So that's why we installed mini conda. It allows us to create these environments. So I have this environment called gsplat. You know it is on when gsplat is here, been activated. So every time we run this project, want to make sure that that is activated, or else nothing will work. Moving along, so Visual Studio setup. Again, this is kind of detailed. I took this from, I believe, Nerf Studio, but basically it says install Visual Studio build tools. If it does not work, you can use 2019. You want to make sure you activate your environment. We already did that. So we had conda activate gsplat, activate your C++ environment. So you want to navigate to your directory where this vsar bat is. And if you don't know where it is, you can just kind of look for it. So I'm just going to go here, hit search, and see if we can find it. So there it is. I can just right click and open file location. Okay, so it was in professional VC. So it's kind of stuck in there. And then you want to run that command. So if I'm here, I'm just going to open up a new command. So just type in CMD in that bar. I'll open up a new command in that location. And then I'm just going to basically put this command in there like so. It's going to activate it. And just basically run what it tells you to do here. This is where some people might kind of get messed up, but once you got this all activated, follow is pretty easy. So I'm actually going to back out of that. So if I go and close that down, just get that all activated. That was super simple for me to use. And then I'm going to install CUDA toolkit. So I already have that again installed, but if you go to this link, I take you to the archive because there's different versions you can get. I have 12.6, maybe 12.6.0. And if you're not sure which one you have set up, maybe you set up all this in the past, you can go to command prompt and type in nvcc -- version. And it'll tell you what you have. So I have CUDA 12.6 as my compiler, as my system. Pretty easy to find. I would suggest using 12.6 or 11.8, probably 12.6. If you're on a newer computer, you have 12.6. and you have Visual Studio 2022, it all should work for you, just to give you a heads up on that. So once that's all kind of put together, then you need to install PyTorch. So I'm in here, I'm in my conda environment still, and I installed PyTorch. I'm going to install it for 12.6. I have 11.8 as well. And if you go to this website, you can find like other versions you can install by just kind of like finding the version you want. Maybe you have CUDA 12.4 already installed, something like that. If you actually have 12.1, I believe you can use 12.4's code. So just kind of match up the right version you have. Oh, here we go. There's your 12.1. So just going back to my project, since I have 12.6, just going to copy this top one here and go to command prompt. I'm going to paste that in and just going to install PyTorch. Okay, so I fast forwarded a bit because it did take a couple of minutes, and now you can see it's done. You shouldn't have any sort of like red text saying there was an error or anything that says trace back. That means you had everything matched up correctly. If something goes wrong, it's probably because you mismatched the PyTorch version to the CUDA version you have installed. And that happens to lots of people for specific reasons of not really knowing which one to grab. So now we need to what's called clone the repository. So at the top of all this, I have all this code that you're going to pull. And you're not actually pulling it from mine. You're going to pull it from the main like actual repository. So coming back down here, it says clone gsplat. So that's why we had git installed at the start. We're just going to copy and paste that top command in. And it's going to pull all of the data from this gsplat project. And this doesn't take very long. Okay, so it's done. Now I'm going to go here where it says cd gsplat. So what we've done is if I go to my computer and I go to my home drive, so usually you have like C users, Jonathan, or for me, whatever your home drive is. So if I actually go to C, if this is all new to you, you should have C users and then your username drive. I just downloaded what's called the gsplat folder. So right here is gsplat, and that's where all the code pulled, and you want to kind of like keep this already open on your screen anyways. And then the CD means I change directory. So if I go to my Windows prompt again, break this down. We are in a gsplat conda environment, and we are now working within the gsplat folder in my user folder. So that makes sense, kind of like we have all the files installed there. So now we have pulled all that data. We need what's called compile it. So it needs to like put all the code together. And that's just really going to use two commands. So this first one is this pip install e, like so. And it's going to run. I'll probably do another fast forward. You can see a lot of text on the screen, but this will take a few minutes. Okay, it's done. And again, no red text. It's done. You might get this kind of like deprecation yellow text. Don't worry about it. You're going to see that. So let's keep moving along. Then I need to install these like requirements. So if I was to actually go to this folder and have this examples folder, this is requirements text. And what it's doing is listing all these things I need to install to run this like additional things. So I just want to go and run this. It's going to install all these more dependencies, and this shouldn't take very long. So if I paste this line here, hit enter, it's going to install all those dependencies. And this again, doesn't take too long. Okay, so everything's done when you see all this text, and it's back to just showing gsplat here. So, and I fast forwarded. I think that took maybe 2-3 minutes, depending on how fast your computer is. And so basically it's installed. The last thing I need to do is this was all set up to work on Linux, not on PC. So we need to replace a specific file or modify a file. And I just made it really easy. So the file you want is called scenemanager.py, and it needs to be placed in your PyColMap folder. So I'm going to show you how to do this last part. So it says you can download directly here. So I'm going to just right click and open a new tab. I'm going to actually close these other tabs for simplicity. And then there's this button here that says download raw file. It's going to download the scenemanagers.py file. And then I got to go find that. So where it goes. So it says it should be in your users folder. So I'm going to go to, I'm going to do this in a new tab. I'm going to go to C, open a new tab. I'm going to go to my users folder, JONAT. Then let's see here, if I can see it all at once right here on the top, it says go to Anaconda 3, like so, ENVS. If you can't find this, you can actually just search for PyColMap on your user drive and find it pretty quickly. And then I'm in this gsplat environment, and then lib, site packages, and last one, PyColMap should be in there. So let's see here. PyColMap, bam, there it is. There's Scene Manager. So I just downloaded that file. So I'm just going to grab it and just kind of drag it in and replace the existing one. So now I have an updated version of that. And it just updates how ColMap manages to handle some data coordinates. So once you're done, you are ready to start. You can either train a scene if you already have data pre-prepared, or I'm going to show you how to prepare your data. So if you've used 3D.js in the past, that format most likely will work just fine for you. You don't need to do anything else. You're ready to go. Grab one of those projects, throw it in your computer. But I'm going to show you how to take a folder of images and make your prepare it on your own. So like I said, the first thing you need is ColMap. So again, here's where to download ColMap. If you don't have it, you just download like the latest version. Just make sure you get the x64 Windows CUDA. If you get the no CUDA, it's going to go slower. So get this one. You're going to download it. And once you've downloaded it and unzipped it, then you're just going to put it somewhere. So I think like I put mine, put it somewhere on your computer, you're not going to change it. So I have in my Jonathan user folder, I have a ColMap 3.9.1 CUDA. And inside there, you see you have like a bin and a lib folder. So once that's all in there, it's on your computer. You just have to tell your computer how to find it every time. So if you go to edit your environment variables, like so, you can go here. You can go to environment variables, and then you want to go to your path, and then you're gonna go from here. You can see I have already added this ColMap folder. So you just add that folder that you had in there. So you hit new, like so. And well, actually, first you want to go where this is. go to this top here. You want to copy that and hit new, paste that wherever it is and hit OK. I'm not going to do it because I already have it in there. But basically, you're telling the computer now where ColdMap is every time you want to bring it up. Super easy. ColdMap's installed. Shouldn't take you more than a minute. So once you have that, you also need one other dependency called Image Magic. Again, I have an installer. I'm not going to walk you through it. You basically just going to download this top version here, and it's like an executable. Again, you're just going to double click it and go through the installer. Okay. Make sure it's added to path. Once you're done with that, you should be good to go. And so I'm going to show you then how to then take my images and downscale them and run them. So if I go to my, I have an old gsplat folder. Let's call this archive2 data, this messy playroom that I showed at the start. I have this images folder. So I'm going to take this and I'm just going to copy and paste it into the project that we're working on. So we have this gsplat project, and I'm going to have you create two new folders. So we're going to call the first one, we're going to call it data. And we're going to create another new one called results, because that's where we want the results to be. But in the data is kind of like where your source project is. And I'm going to paste, I don't want the images folder there. I pasted it in there, but I'm going to create a new folder. I'm going to call this one Playroom, because that's what it is. And drag that images folder in there. So every single project that you run will need a project folder that's in your data folder, and within it, a folder called images with images in it. So if I bring that up, you can see these big, wide, fisheye camera images of my kids' very messy playroom. They're not perfect. You can see my arm got caught in several of these. It's not perfect, but I didn't want perfect. So I'm just going to go ahead and close this. But if I go look at the properties of these, so go to properties and go to details, you can see that they are like, let's see here, 612, they're 24 megapixels. That's not going to work for what I want. I actually want, I want these to be smaller because you're not going to run on your GPU. So I'm going to downscale these by half. So I taught you how to do that. Oh, and here's how you're supposed to have it. You have your, your location, your images folder, and at the end we're going to have these sparse 0 cameras, points, things like that. So let's downsample. So I'm going to then go to this projects folder, which I was in. So I'm in C user Jonathan. If you want to get into the folder I need to work in, I'm going to go change directory, that CD command, and I'm just going to change it to this playroom folder, like so. And just copy that, paste it. Now I'm in that folder. It's an easy way to get to it. And from there, I want to make a new directory. I think this is actually a little old. It should just be like this. I'll make sure I update it before you have you guys run it. But now you have this images 2, which is empty. And then we want to run this to make your images half scale. So I'm going to go back to command line. Okay, so now I have that images 2 folder, and we need to basically get half scaled versions of that into this. And so we're just going to run a command prompt again, go to command. And if I just copy the second line, it should do what we're looking for. I see actually had, as I'm going here, I actually see that I had the wrong version in here. So, but I will update the repository to have the right one, but you're just going to copy and paste that. And so it's going to sit here and it looks like nothing's happening. But just know that if I go to my folders, you'll start to see like these half scale folder images start to populate. There's actually not a really good one in there. I would go, if you have the time, I would go and delete any that like don't make sense. Like this one's really, really dark. So that's not ideal. So once this is done, I'm actually going to go remove that one. So go to command prompt, you can see it's done. So where's that dark image? Take that guy, I'm going to delete him. And then I want to make sure I do the same. You want to make sure whatever you do for one, you do for the other. So there it is, delete those guys. And so now I want to I have my half scaled. So I have my images and my images too. Now I want to run Colmap. And there's two ways to this. So I have that installed. If you're really comfortable using the code, we can do this, but I'm going to show you more an interactive way. So I'm going to go to, my Colmap, like this, type in Colmap GUI, and it'll launch the GUI. So if I go to the directions, I'm going to go to the newbies GUI path. So just basically, I realize again, I have a flaw in my instructions. Just do what I did. For this Colmap GUI, we're going to go to step 2. I already have it installed. So if I go to step 2 here, I'm going to do a Colmap GUI, and I'm going to go to File, New Project. I'm going to hit New Database. I'm going to find, I'm in this Playroom folder. Perfect. And I go to database.db is the file name. Hit Save. And then select images. So I'm going to select that images folder like so and hit Save. And then I'm going to go to Processing. And from the processing, then I want to do feature extraction. And since I am using a fisheye camera, I want to make sure I'm using OpenCV fisheye. If you're not using it, you're just using like a regular standard camera, you just want to make sure you pick pinhole or simple pinhole. Either one will work. Just do pinhole. And then make sure you say share for all images. We're using the same camera for all these images. I didn't use more than one camera. Hit extract. I only had, 49 images. This should be pretty quick. You'll see it's extracting, and when it's done, this little dialog box goes away. Okay, so that's done. Then I'm going to bring up feature matching. Again, I can do exhaustive. If you take all your pictures in a row, so I'm just like walk around, well, the next photo always connects with the other photo, do sequential. But because I took them at random, I'm going to do exhaustive. I hit run. Inner run matching. Again, this shouldn't take too long just because I have such a small image set. So that's done. Now the last thing is reconstruction. Just go ahead and hit start reconstruction. Everything should be set up just fine. And you'll start to see the scene reconstructing. So there it goes. And it's starting to find matches and reconstructing the scene. So make this bigger. And you can start to see that it's mapping out the camera locations. And that's what we need. Okay, so it's done. Gone through all the images. Now we just need to export this model. I'm going to go to File. I want to export model as text. And I want that to be in this Playroom folder, but not exactly. I explained that needs to be in a folder called Sparse. Then within that folder, it needs to be in another folder called 0. So like that, select folder. And so now if I go to my directory here, you'll see data, playroom, sparse, 0, and these camera.txt, images.txt, and points3d.txt. Perfect. My data is ready to train. Timeout. I figured if you're halfway through this and you want to run this project, you are wanting to watch my type of videos. So I just ask that you simply subscribe to my channel, leave a comment if you like this video, because that's what fuels me to keep moving. I am not monetizing this and making it a job. I do it as a hobby. So I want to keep this up. I want to make sure you guys are liking what I make, and I like what I make. So let's get back to the video. So we're getting very close to being ready to make your very first scene. Now we're in the training part. So I told you this was like a lot of setup. You can script a lot of this once you ever have the project set up. Running this project is super fast. So you have two ways to run it. You can run it with a fisheye camera or the regular pinhole camera. You choose which one you want. I use the fisheye camera for this one. And so if you're not using that type of camera, you want to make sure you use a regular camera. And so I'm going to open up my notepad. Trusty notepad, and start like this. And I'm just going to copy this top line because I need to actually make a little change in it. And it's easier to do it here than in command line. So I'll make this nice and big. What it's saying is you're going to run Python. It's going to use this Python script called Simple Trainer. It's going to train using the MCMC densification process. And then it wants to know what my data directory is. And so that was in the data/playroom. So very easy for you. Hopefully you call something else unless you're doing an actual playroom. Data factor. So I'm telling to use half scale. If you leave this out, by default is quarter scale. And if you make it 1, it's going to pick the full scale. So if you don't have very high resolution images, you can try 1, you can quarter, you can half scale this stuff, whatever you need to get it to work. I don't leave it at 2. The results directory is, so we made that results folder. So I'm gonna make this sure this goes into, let's kind of call it Playroom, like so. Camera model, make sure for me it's fisheye. The only difference between this script and the other script that said pinhole is that this parameter is left off because default, it's a pinhole camera. And then we want to add these last two things, with UT and with eval 3D. And that's what will make it work with Gaussian Unscented Transforms. So go here. Oh, this is still running. We're still running CoolMap. So I want to make sure I quit that. So you can close, I can just close CoolMap like so. And then I want to change my directory back to gsplat if you're in the wrong spot. So to do that, you just if you hit cd ... it takes you back one. So I can just keep doing that until you're at the right one. So there we go. And then I'm going to paste that Python script and hit enter. So now it's going, the first thing it's going to do is it's going to downscale my images. So again, it's making yet another folder. So if I go to my Playroom, you can see now there's an images 2. So it's making like a PNG version. I don't know if that's because it needs everything to be in PNG to run or what. I run into that in every data set, but I've used JPEG for every data set. I can look into that later. If it doesn't do this, it's because you probably already have the right type of images. And this will take a minute. So I'm going to actually just pause this video and come back when it's getting fun again. Okay, so now it's all training once it's copied everything. And for me, when it starts training, it'll say this, you can go to your HTTP localhost 8080. That should work for you. Sometimes it will show the wrong path. So I don't know. You know it's training when you start to see this kind of like loss and spherical harmonics going, and it should give you an estimated time. And that's not, I want to say that's not always accurate because it's saying 30 minutes. I think this data set took 40 minutes in the end. It can slow down as time goes on if it needs to. But I can go watch this train interactively, which is really cool. So if I go here, I hit control and clicked on it. You can see the scene is starting to train. So it's a really cool process because it's not like 3D Gaussian splatting. It's a little different. It's like these ray traced pixels that just start to kind of like grow and fill the scene, as opposed to like, bam, you have the whole scene and then it kind of like gets small. So it doesn't look great here. And you can sit here and you can watch it. You can even pause training. You can see how many steps you're at. And you can play around with these different things in the viewer. But that's not what we're here for. In fact, I can move my head over here. There's like keyframes. And this is, if you've used Nerf Studio, this is it. This looks cool. It's functional. But it's just a way to watch. And I can tell you, if you have this open like this, while it trains to 30,000 steps, and you can change the arguments, by the way, to add more steps, things like that. Just know that this slows it down. So I typically close this screen, let it train, and come back when it's done because this is just slowing down everything. But I just want to show you how easy it is. You can use your WAS keys, things like that. But I'm going to show you what it looks like when it's done. But before I do that, I'm just going to, again, close this visor window. And as you can see, as it's going, it kind of like hits these 100 splats and then creates another line. You can watch the loss. Just know at 7,000 steps, it's going to pause and you're going to be like, uh-oh, did I break it? It's not working. It's actually running an eval. It's going to tell you what the PSNR is. That's the peak signal to noise ratio. It's basically an indicator of quality. You want it in the 30s if possible. It means you got really sharp, good images. If it's in like 10, you know something's gone wrong. And you can actually see kind of some of the outputs. So as it's going, you can go to your data, your gsplat results, and now you can see I have this Playroom folder that it created, and there's these checkpoints it's going to create. So at 7,000 it like saves, and at 30,000 it saves, and then it's going to like do these just different renders. So I can show you what one of those looks like when it's done. So I'm actually going to let this run the whole time because no one wants to sit. If you hit Control C, it'll stop things, and like so, we're going to quit that, and I'm actually going to cheat. I'm going to go to an old run of this data set when I was testing, like so, and it's called it's called results. I call it Playroom 2. We'll just take that one. and put it in here like so. And it should have this checkpoint, and you can see there's my like 6,000 and 30,000. And I can load one of those up to view after the fact. So as you can say, rendering. So now we want to render that. So I'm going to basically, again, copy and bring up my trusty notepad. And I'm going to change this checkpoint folder file to where it actually is. So for me, I'm going to go to Windows Explorer again. Just actually, it's this. I'm just going to right click and I'm going to hit copy as path, paste that. And I believe I can just actually use that. So let's see if that works. So just going to copy that guy, go back to this, and I'm going to paste that. And let's see if it loads it up. I may have to also pull the source. I don't think so. Okay, so it's running. Ended up with 1,000,000 Gaussians. That's, I think, the cap. Again, there's all these arguments that you can do to show, and I'll show you at the very end how to do that. But if I go to, again, the local host, it's going to bring up this viewer. There we go. It took a second to load. I was getting worried there. And I'm just going to zoom in. Bam, there it is. It's going to look terrible, and you're going to be like, oh, what's going on here? Just go to this up here and check mark that, and bam, it does the transform. So now things look a lot better. I think the scene would have looked better if I had taken out that dark, what do you call it? That dark image. I think it kind of messed up around here. But again, you got this cool scene, and this is a really cool viewer. So I'm looking at a pinhole, or you can make it look like you have a fisheye camera. So this is basically copying the camera type I had, this fisheye camera lens. And then you can even play around with like the distortion coefficients. And now you got that like small world look. You can just play around with all those. Again, the WASD will move you like forward, backward, left, right. E and Q will be up and down. You can play around that way, and your mouse. And then you can go back to pinhole. I think that's a better version. I don't need this all to be tiny like so. And this is really cool because then you can start to even do like rendering and things. So you can even like add a keyframe and add a couple more like so, and start to create an animation. I'm not good at this. Well, I used to be good at this. So add keyframe like so. So now you can start to see like an animation path being built that you can watch. I think there's a way you can actually loop. Yeah, it'll loop you back around like so. I think that's a pretty steep looking loop. But you should be able to preview that render like so. This is kind of jerky, but I mean, I didn't spend time on this, so you can make it look better. I know it'll render smoother than that, but there you go. So you know how you can do that. I think part of the problem is I didn't play with the spline tension as well. So if I exit that preview, there's this spline tension. And yeah, I always found that if you bring all the way forward and backwards, it will make things better. So I wonder if that improves things. It's still jerky. I think they fixed that in the final render though. This is just a preview. So anyways, that gives you an idea. You can say like how long, how many frames you want this to be, how long between each of those keyframes, and you can do really cool, yeah, enter this. You can do pretty cool things. And then I think the dump video will render it. So there's different things that you can do to render this. And I think you can even run this in fisheye like that. So you can get these like cool fisheye fly arounds. And that's how you run it. So I'm going to go ahead and close this visor, but that's just an easy, awesome way to view everything. If I hit Control key, it's actually still running that, even though I closed the window. Okay, there's this other, also the more comprehensive viewer from Nerf Studio as well. I'm going to bring that up. Let's take a look at that. I actually haven't ran that yet. This will be new. Go here. Again, we want to change this results file. Bad on me. I should have done this in Notepad, but we already know what this checkpoint is. If I go up, I can just grab it from here like so. I'm going to copy that, paste it in, and it'll load up that checkpoint. Okay, now it's again running the viewer. And then, yeah, here's your gsplat viewer. I think it takes a second to go here. There we go. So here's the gsplat viewer, and it views right. So This you can't play around some of the other things, but I think there's some other options that you can play around with in here. So that kind of gives you an idea what you can do for the viewer. I don't know if this, I think a lot of this is actually very much the same as the specific viewer for looking at the GUT viewer. Okay, so that's basically it. If you got this far, I notice I'm missing something from the instructions that will be in the GitHub as you're copying and pasting, so you won't have to worry about it. But I did not talk about how to save a PLY file out so you can put it in Supersplat or whatever. You basically just put dash dash save underbar PLY. Totally omitted that, but I will make sure I add that to the instructions as it makes sense, because most of you will want a PLY file out of it. So from here, you can play around with that visualizer. If you're watching this video within the time frame which NVIDIA is running their sweepstakes, go ahead and enter with making some cool visualization. Feel free to ask as many questions as you want in the comments to this video. I love answering as many as I can. Just let you know though that it might not be instantly. So you can always jump on the original GitHub gsplat issues and put one in there, and they are really active in answering your questions as you go along. So I hope you find this video was helpful. I'm really excited to see what you make. If you put anything on social media, please find me and tag me. I would love to comment and share on it. And if you found this video helpful, please, please, please give me a follow, because that is what fuels me to make more of these. And with that, I'll see you guys in the next episode.